Starting off our exponential unit, we're going to look at graphs of these exponential functions just to see what they look like at first. Because again, we're leaving straight lines behind. That was linear. We're working on exponential functions. On your formula chart, look at the formula chart for a second. This formula right here that is printed on your paper, do you see that anywhere on your formula chart? No, this is not on your formula chart. This is a formula we have to memorize. But check it out. Look how easy it is. It's alphabetical order, AB. Can y'all remember AB? Okay, great. The A is going to be my y-intercept. So it still tells me my y-intercept, like y equals mx plus b, but it tells me that number first. The A is the y-intercept. This b value, what do you notice about the b value? What's next to it? The x. And what is the x? Is it a regular x? It's an exponent. Do you see how it's little and it's floating? That's an exponent. The exponent is touching the b, so that makes our b our growth or decay factor. So that's what we're going to be multiplying by. So just like our sequences that we just did, where some of them were added, that's like linear, and some of them were multiplied, that's going to be like exponential. So let's fill in some words here. An exponential function. Exponential function looks like the word exponent, so we know we're going to have an exponent, a variable exponent, so the x is an exponent, for this to be an exponential function. It's nonlinear, which means our graphs are going to be curves. Don't call it a line anymore, it's called the curve. Okay? So let's talk about things we're going to see in an exponential graph. This is going to be super important. We still will find a y-intercept. Again, it's the letter A. That's going to be my y-intercept. I wrote that word kind of big. That is where the graph crosses the y-axis. We know how to identify that. We can look at a graph, point at the y-intercept, and say, 7 or 5 or whatever the y-intercept is. Easy peasy. It's also the value of A, the first number in your equation. The second thing that we're going to fill in here is the growth or decay factor. Oops, that's a highlighter. Growth or decay factor. It's called a factor because that's going to be the number that I'm multiplying by in this equation. So I'm no longer adding a number, the same number every time. I'm multiplying by a number every time. Just like those sequences did. Some of them got really big really fast or really small really fast. That's what's going to happen with these exponential functions. The next vocabulary word that I'm going to introduce to you, I don't know what I was just about to say. The next vocabulary word is a part of a graph that is invisible, but you have to know exists. It's called an asymptote. Try saying that word out loud without giggling. Asymptote. That's a real mathematical word. It is a invisible horizontal line that this graph is going to get very, very close to but never touch. It's called a boundary line. So it's going to be not really actually graphed on your screen, but you know that it's invisible in there. So I'm always going to draw them as dashed lines because they're invisible. But we know it's a boundary line that's there. In fact, we know this boundary line is the exact same answer every time. Hear me again. It is the exact same answer every time. You're going to tell me that the asymptote of these graphs is y equals 0. The horizontal line at 0. That's not going to change in this class. That is the answer. Every time I ask you what is the horizontal asymptote, you're going to say y equals 0. Right? That's a fact we need to know. Now, a little bit about the asymptote. If we look at this graph here, okay, this is what an exponential graph might look like. Is it a straight line? No, it's a curve, right? This curve has a boundary, and that boundary is down here at y equals 0. This graph is going to get very, very close to, but never touch this boundary line, because it literally can't. And I know some of you are looking at that like, Miss Quigley, if you kept drawing that, it would totally touch. I'm going to switch over to Desmos for a second, which means people watching the video, you won't be able to see this. And I'm going to show you what happens when we zoom in really closely. Fabulous. All right, so since we're looking at this graph, we have the equation that made that graph. We have the table of coordinates. All of these things are things we did for linear equations. We can do the same thing for exponential. We can also identify some of the attributes for this graph. So let's do this one together. It asks me for the y-intercept. We can look at a graph and show the y-intercept. Where is this crossing the y-axis? Ooh, the y-axis, guys, the vertical axis. What number is that?
16.
Okay, great. Here's what I want you to notice. Yes, the y-intercept is 16. Where else do you see a 16 in the equation graph or table? Next to the 1/2. It goes first. That's a. Remember ab to the x? A is the y-intercept. Where else do you see a 16? On the table partnered with what?
0.
All of these ways, an x of 0, the y is the y-intercept. All of these things we can use to find the y-intercept. So if you're nervous that the equation's not telling you the right number for the y-intercept, throw it into Desmos or your calculator and look at it and make sure it actually looks like it's crossing at 16. The multiplier is the b value. Yeah, so what's the b value? 1/2. The only other number that exists in this equation tells me what's happening every time. Now, would you say, based on this graph, is this graph going down or going up? So would that be a growth graph or a decay graph? Decay, yeah. Growth means it's going to go up. Decay is the words that we're going to start using to talk about graphs that decrease. So decay and decrease will always go together. Growth and increase will always go together. My last question for you, and we should all know the answer to this. What's the equation of the asymptote? Boom. Y equals 0. Every single time for this class, the asymptote is y equals 0. It will never change. Thank you for your awesome questions. Let's pop to the back of this and do a couple more examples of doing this graph. What do you notice this time about example 1, though? I don't have a line, and I didn't give you any numbers in this table.
The 10 is a line.
Oh,
So the 10 is a y-intercept.
the 10 is going to be my y-intercept. Oh, that's a whole
Oh,
marker.
you started with 0, then you...
I love that y'all knew that. So where can I put 10 on my table?
The first one.
The first one with -2? What is it partnered with on the other side? On 0. Okay, so there's that. And I can also plot that point. I can go to 10 on the y-intercept and put my first point. That's the y-intercept. Wow, look at all these things I know just by knowing 10 is the y-intercept. After this, you can either do a whole bunch of math on in your head in the calculator, or I'm going to show you something very cool on Desmos. Okay? Okay, so we went to Desmos, we typed in the equation, we converted it to a table. So that's settings, convert to table. Again, it gave me all of the values that I want to put into this table that go along with it, which for me is going to be 17.7 and then 13.3. We already have the 10, 1, 7.5, 2, 5.6, 3, 4.2, and 4, 3.2. 3.16 would round to 3.2. Okay, well, there's a whole bunch of coordinates I can plot. 3.16, so it will round to 3.2. So we can plot all of these points. If I go to -2 on the x-axis, I need to go up to 17.7. Well, that's off the graph. So let me go to -1, and then 13.3, just give it my best estimation of 13.3. And then we've got 0, 10, check. 1, 7.5, 2, 5.6. Does everyone see how I'm doing this? 3, 4.2, 4, 3.2. That's all the numbers I have. I can play connect the dots, but I need to be aware of my boundary line. There's an invisible boundary line that this graph cannot cross down here. It's called my asymptote. So when I play connect the dots, I can connect these dots together, but I have to make sure I don't touch or cross that boundary line. It makes my exponential equation. So don't cross this purple line. You can't. You can't touch it or cross it. It's got to get extremely close. Yes, sir. Yes. Let me give you a second to get your graph to look really nice like mine. All right, we've got our graph. Let's fill out the attributes here, the vocabulary. What was the y-intercept? We already answered this, but 10. Amazing. It's the first number of my equations where the graph crosses the y-axis. Awesome. What's the multiplier? 3/4, or you can just put 0.75, but I love that you knew that was 3/4. I love fractions.
So whatever's in the parentheses is your multiplier.
Absolutely. Whatever is in the parentheses is called b, so that's my multiplier. So you have a and b. Fabulous. Okay, is this growth or decay? Why is it decay again? Because it's going down. Does that mean it increases or decreases?
Decreases.
Amazing. And what's the equation of the asymptote? Y equals 0. My x-axis. Y equals 0. Cannot cross it, cannot touch it. Do y'all feel like you could do number 2 on your own?
Yep.
Okay, I want you to try it. Go ahead and do number 2 on your own. For those of you who are waiting, we here have our table and our sketch. And then we can just answer the questions. What did you guys get as the y-intercept? 18, because that's the first number of my equations where the graph crossed the y-axis. What's the multiplier? What's the factor? 0.5 or a half. That means it's going down by a half every time. Does that mean it's growing or decaying? Decay, because it's literally going downhill, which also means it's decreasing. And what's the equation of the asymptote? Amazing. We should be able to do the rest of these problems. Do y'all feel up for it?
Yeah.
Okay, great. You've got numbers 3 and 4 to work on your own. I'm going to come around and check on you as you work. All right, on our next page of our notes here, we're still going to be talking about the graphs of exponential functions. We just took a second to think about the vocabulary. We had the increasing and decreasing with the b values. We had the graphs, all that stuff. So thinking more about the graphs. Another thing that we generally talk about when we talk about graphs of functions is domain and range. We kind of talked about this in our warm-up, but what is domain? Is it the x's or the y's? The x's. So everybody circle the d, x, and I. Dr. XY, where's her ID? Yay. It's going to help us remember that domain is the x's or your independent variables. What's range?
Y.
The y's, your dependent variables. Another thing I want us to remember is that domain is describing the graph from the left to the right. And that range is describing the graph from the what to the what?
Left to right.
What? Range?
Right to right. Oh no, bottom to top.
Bottom to top. That's Dolor the robot, bottom to top. We also talked about this in our warm-up today, but we have our open and our closed circles. Do you remember that from our warm-up today? That's going to be important for us to answer our questions. We're going to review first, before we talk about exponential domain and range, just domain and range with linear equations. If we look at this guy right here, and I ask you for the domain, I'm asking you for where the graph shows up on the x-axis from left to right. What's the furthest left that this graph goes? Negative what? Negative 9. That's as far left as it goes. And then it goes all the way to what number? 2. So we're saying all of this part of the x-axis is a part of my domain. The way that we write the math sentence that describes from negative 9 to 2 is as follows. We'd say the left number, negative 9. It's an open or a closed circle? Open, so I'm going to use just less than. Domain is the x. Then I got to go to 2, but it has a closed circle, so that's 2. We're saying from negative 9 to 2. That's the mathematical way of saying that. We haven't talked about this in a minute, so I know we're dusting off some cobwebs here. The range is from bottom to top. What's the lowest that this goes? What's the highest that this goes?
3.
So we're saying the range, or the y values used, is all of these numbers. From negative 6 with a closed circle, all the way to 3 with an open circle.
So is it literally just the same thing like we've been doing, or is it anything different to it?
This is still linear, so this is just a review of that, yeah, so it should be the same. Negative 9 to 2 with an open circle and a closed circle, and then negative 6 to 3 with a closed circle and then an open circle. We have to get the notation correct. Knowing what it is half the battle, and writing it correctly is the main problem when it comes to domain and range. In fact, domain and range gets a little bit more complicated when we do problems like this. You guys were actually very good at this kind of problem, so I'm not that worried about it. But if you look at this domain and range, we still go left to right. What's the furthest left that this graph goes? Negative 4. And is it open or closed? Closed, so I put the line underneath the symbol. But if I look on the right side, does that mean that it stops? Does that arrow there mean that it stops? No. What number does it go all the way out to? Infinity. So we're saying that the x values we use go from -4 all the way out to infinity and beyond, LOL. Okay. Now we don't answer questions like this. In Algebra 1, we don't include infinities in our final answer, so I'm actually going to cross that part out. But answer choices will not start for one-sided inequalities with the number. We're actually going to start with the letter. So if I wanted the letter to go first and then the number, do I use the same exact symbol? No, you have to keep the orientation the same. So I want the closed side next to -4 and the open side next to x.
What?
So I had to flip the symbol around.
Oh, because it was on.
Because we flipped the side, so we flipped the inequality. That's just to rewrite it in the correct notation. Technically, if you'd answer this one, you are not incorrect. That's a correct statement. But you're not going to see answer choices like that, and mathematicians don't write their answers like that.
So it would only be flipped if it's an error, like if there's an error. Like that's the only
Basically, yeah, it will only be flipped if it's a one-sided inequality. If there's one arrow, you might have to flip it.
And you always flip it?
Not necessarily, and we're going to see why just now. So his question was, do you always flip it? Well, let's look at range. What do you notice is at the bottom?
All the numbers?
With the arrow that goes to infinity. This one's going to go to -infinity because it's going down. But what's at the top here? 6 with a closed circle. Okay, so again, I can't use the -infinity part, so I'm going to mark that part out. Do I need to flip this one?
Yes.
Doesn't the letter need to go first?
Yeah.
Isn't the letter first?
So you just box it.
Oh,
So just box it. So you won't always have to flip it because I just need the letter to go first.
Oh, okay.
You could flip it. Technically, that's still a correct mathematical statement. We just don't write our answers with the numbers coming first. Not because of the negative. That's if you multiply or divide by a negative number and you're solving an inequality. That's a good question. Okay, so quick review of linear. Let's apply these ideas of left, right, bottom, top to exponentials. On the back side here, we have some practice problems. This is no longer a straight line. It's a curve. Nothing changes. Nothing changes. So we look. On the left side, what number is there? On the right side, what number does it extend all the way to? To 3, right? On the x-axis.
Yep.
So my domain is going to have the numbers -2 and 3 in it. What symbol do I put on this side?
No. Wait.
Is it less than or less than equal? Why is it with the equal to?
Because it's close.
Because it has a closed circle. Very good. Now what symbol do I put on the other side?
Less than.
Just less than, because that's an open circle. Awesome. Let's go to range. Bottom to top. What's the bottom of this graph?
2.
What's the top of this graph?
12.
12. Okay, so I know I'm going to have 2 and 12 in my range. I just need to pick the right symbols. I've got a closed circle on the bottom and an open circle on the top. So closed gets the line underneath it, open doesn't.
That's it?
That's it. That's the domain and the range. To prove that we understand this one, can you guys do the next example just right next to it here? Sure, you got it. I believe in you.
I don't understand.
I'll come over there for a second. Okay, so I'm seeing really good things. Here's what I'm seeing. I'm seeing we are identifying the numbers correctly, but some of us are getting them out of order. Don't forget that domain they're both smaller to larger. The smaller number needs to go first, then the bigger number. So that means that domain is left to right, because smaller numbers are on the left. And that means that range is bottom to top, because smaller numbers are underneath. That's why it's left to right, bottom to top. It's just number order. So that means that the domain, our numbers are -6 and 8. The first number, -6, has an open circle, so I give it the open symbol. The second number has a closed, so I give it the closed symbol. When I get to the range, again, going smallest to largest is bottom to top. The bottom number is 2, the top number is 8. Bottom number is closed, top number is open. How'd we do?
Excellent.
Let's go on to the next kind of problem here. This one. What do you notice automatically about this kind of question, this kind of graph?
It's an arrow at the top.
There's an arrow at the top, so it's going to be one of our one-sided ones because there's an arrow on one side. Okay, great. Let's start the process like we always do. Domain, here's the left, but on the right, I see this arrow, which means on the right side, I'm going all the way out to infinity. My number is -3 with a closed circle and all the way to infinity. But can I leave my answer looking like that? No, I'm going to mark out the infinity part
Flip it, girl.
and flip it because I want the letter to go first. Both of them are acceptable answers, but will only be written in notation with the letter going first. Let's talk about the range, though. How low does this graph go? What's the lowest it goes?
At
3 with a closed circle. How high does it go on the top? Infinity and beyond, LOL. Yep, thank you. So we have infinity on the other side. Can we leave infinities in our answers?
No.
Not in Algebra 1, so we're going to mark it out. Do I have to flip this one?
Yup.
I flip everything. Y greater than or equal to 3. Now notice, this makes sense. I'm saying that the graph shows up everywhere above 3. Is that where the graph shows up? That's everywhere that's above 3. So if you flipped this and it said everywhere below 3 because you didn't flip the sign, that would be down here. Is that where the graph shows up? No. Okay. You guys got the next one. I want you to try the next one on this row.
Oh.
Amazing. Keep working. Here we go. The next one. Just going over this. I think most of us got this one. Here's where our domain starts and it ends at infinity. So my math sentence would say -2 less than or equal to x less than infinity, but then I'm like, whoop, can't write that part, so I flip it around. X greater than or equal to -2. So everything bigger than -2. That's exactly where the graph shows up. That makes sense. If we look at the y values, this is 1.5 in between 1 and 2. And then we have infinities at the top. So it goes from -0.5, I'm saying all the wrong words. 1.5 to infinity. So we write that as y greater than or equal to 1.5. Let's talk about the next two. This one's kind of interesting. What do you notice about this graph? 2 arrows. Amazing. Let's not change what we're doing. Let's keep thinking in this process. If we look on the left side of this graph, we have an arrow. That arrow means this is going out to -infinity. On the other side, we have an arrow. That means this side's going out to infinity. Just like on our warm-up today, when you have the double infinities, what do you say as the domain? All real numbers. Now, I know it's very tempting. Oh, yeah, by the way, you can use the fancy R. It's very tempting to think, oh, double arrows means the range is also all real numbers. But what did we learn about today that exists right here? It don't touch. Does anybody remember what that's called? It's the asymptote. Can the graph ever cross that? Y equals 0? No, so that's the lowest it can go, is 0. What's the highest it can go?
0.
For real?
What?
Isn't that arrow going up?
Ready?
What's upwards?
Yeah. Oh, infinity.
Infinity. But I can't write infinities. So this is going to be y greater than 0. It has to be above 0 because it can't cross or touch 0. Amazing work. I want you guys to try the next one. What I want you to notice about the next one, before I let you try it, is this an arrow?
No.
No. Right now, just to make it a little bit easier for you, since it's not an arrow, I want you to put a little dot there.
Close or open?
Closed. Okay, give it a shot. All right, let's check it. The domain. What does it start at? 0. Where does it end?
Infinity.
Never. Infinity. Same thing, sort of, I guess. Which means that we go from 0 with a closed circle up to infinity.
Reach that.
Switch it. X greater than or equal to 0. What's the lowest that this goes?
10.
That value is 10. Very good. We actually had to read a graph this time. And what's happening at the top of it?
Keep going.
Keeps going to infinity. never stops. So we have from 10 with a closed circle all the way to infinity. But we don't use the infinities and we flip it. Domain and range, complicated. I totally understand that. But we're going to get better at it as long as you keep remembering to draw those arrows left, right, bottom, top. Do I have any major questions before we end our notes for today? Okay. Thank you for hanging on.